Download this code from codegive.com, link in the description below. Pyspark tutorial, Big Data Handling with Python and Apache Spark. Introduction to Pyspark. Apache Spark is an open-source distributed computing system that provides an interface for programming entire clusters with implicit data parallelism and fault tolerance. Pyspark is the Python API for Spark, enabling Python developers to harness the simplicity of Python and the power of Apache Spark for big data processing. Why use Pyspark? 1. Speed. Spark processes data in memory, making it faster than traditional disk-based systems like hadoop mapreduce. 2. Ease of use. With Python's rich ecosystem, Pyspark makes it easier to work with big data. 3. Unified engine. Spark supports batch processing, streaming, machine learning, and graph processing. Setting up Pyspark. Installation. You can install Pyspark using pip bash. Pip install Pyspark. Starting a Pyspark session. To start using Pyspark, you need to create a Spark session. Python. From pyspark.sql import Spark session. Create Spark session. Spark equals Spark session.builder /. App name, Pyspark tutorial, /. Get or create. Working with data frames. Data frames are a distributed collection of data organized into named columns. They are similar to Pandas data frames but optimized for large data sets. Creating a data frame. You can create a data frame from a variety of sources, including CSV files, JSON files, and existing roads. Example, creating a data frame from a CSV file. Python. Load data from a CSV file. df equals spark.read.csv, path /to/your/file.csv, header equals true, infer schema equals true. Show the first few rows of the data frame. df.show. Data frame operations. You can perform a variety of operations on data frames, including filtering, aggregating, and joining. Example, filtering data. Python. Filter the data frame. Filtered _df equals df.filter, df column _name 100. Show the filtered data frame. Filtered _df.show. Example, aggregating data. Python. Group by and aggregate. Aggregated _df equals df.groupby, column _name, .ag, another _column, mean. Show the aggregated data frame. Aggregated _df.show. Example, joining data frames. Python. Create another data frame. df2 equals spark.read.csv, path /to/ another _file.csv, header equals true, infer schema equals true. Join the data frames. Joined _df equals df.join, df2, df key _column equals df2 key _column, inner. Show the joined data frame. Joined _df.show. Working with roads. Resilient distributed data sets, roads, are the core abstraction of Spark. They are fault-tolerant collections of objects that can be processed in parallel. Creating roads. You can create roads from existing data or by parallelizing a collection. Example, creating roads. Python. Create an RDD from a list. Data equals 1, 2, 3, 4, 5. RDD equals spark.sparkContext.parallelize, data. Collect the RDD. Print, RDD.collect. RDD operations. Roads support transformations and actions. Example, transformation and action. Python. Map transformation. Squared underscore RDD equals RDD.map, lambda x, x2. Action to collect results. Print, squared underscore RDD.collect. Machine learning with Pyspark. Pyspark provides a library called mlib for scalable machine learning. Example, logistic regression. Python. From Pyspark.milliliter classification import logistic regression. From Pyspark.milliliter feature import vector assembler. From Pyspark.ml import pipeline. Prepare the data. Data equals spark.read.csv, path/to/your/data.csv, header equals true, infer schema equals true. Assembler equals vector assembler, input calls equals feature 1, feature 2, output col equals features. Training underscore data equals assembler.transform, data. Train the model. LR equals logistic regression, feature col equals features, label col equals label. Pipeline equals pipeline, stages equals assembler, LR. Model equals pipeline.fit, training underscore data. Make predictions. Predictions equals model.transform, training underscore data. Predictions.select, features, label, prediction, .show. Conclusion. This tutorial provided a basic overview of how to handle big data using Pyspark with Python. You learned how to set up Pyspark, work with data frames and roads, and perform machine learning tasks. Additional resources. Apache Spark documentation, https://spark.apache.org/docs/latest. Pyspark API documentation, https://spark.apache.org/docs/latest/api/python/index.html. Databricks Community Edition, https://community.cloud.databricks.com. By utilizing Pyspark, you can harness the power of big data and perform efficient data processing and analysis with Python. Happy coding!